Hello everyone and welcome back to the channel. So in today's video, we want to further discuss some PyTorch because we are focusing on machine learning, and PyTorch is one of the main libraries used to build modern AI systems, even used in ChatGPT, all the image generators, and even all the recommendation. Basically in all of the AI and machine learning tools, PyTorch is the core tool that is used. So even if you're a beginner, don't worry, I'll explain everything step by step. And if you know Python already, you'll learn new things about how they actually work. So in the previous part of this series, we built some GPT models and we also built a chat model, and we implemented PyTorch when we were building those models. So therefore, I feel like it's necessary to cover some PyTorch as well on this channel. So if you guys are ready, let's go ahead and begin. Okay, so first let's go ahead and import PyTorch and check whether it works on our system. So all you do is import torch, then print torch version. And once you run that, you should see the version of PyTorch, and that means you have successfully opened PyTorch library. Now moving on, we want to discuss tensors, because tensors are one of the most important concepts in PyTorch. So basically a tensor is just a container for numbers. So if you've used Python or NumPy, you'll recognize them similar to lists or arrays, and it will feel similar. But the key difference with tensors is that the PyTorch tensors can remember the operations and calculate the gradients. So this is what makes them machine learning possible, using tensors instead. So now I want to show you guys an example, just a simple tensor. So here we can go and write tensor example equals torch.tensor. Just random numbers, 1, 2, 3, 4. Basically, we're making a list here. And then we print tensor example. So once we run that, we should see the tensors has been printed. And this is just a basic operation, just to show how the tensors work and how they store the variables. We can also print the shape of the tensor, which will show us how many numbers are in the tensor and how are these numbers arranged. So in AI, shape is extremely important because the models expect data in very specific formats. So just for this example, we can go ahead and write out print tensor example.shape. And once we run that, you should see torch.size 4. So there's 4 numbers. And next we can also dive into some basic operations with tensors. So this is where things get interesting, because while the tensors can hold data, you can also, similar to the lists and arrays, you can also perform operations like addition, multiplication, and even matrix manipulations. So just for an example, let's add a couple of tensors. So let's make tensor A equals, let's say, torch tensor 2, 3, and 4. Tensor B, torch.tensor, let's say 5, 6, 7, 8. Okay, so now for instance, we can add both these tensors. So we'll just do sum tensor equals tensor A plus tensor B. and we can print this sum tensor. And once you do that, you will see that both these tensors have been added together. So 1 and 5, 6, 2 and 6, 8, and so on. So as you can see, the tensors can be manipulated just like the NumPy arrays, the Python lists, but the additional advantage is that we have the option to use them on GPUs. So this is why we use the tensors. And now let's talk about one of the most important features of PyTorch, autogradient. So autogradient, or we call it autograd, allows you to compute the gradients automatically, which is an essential part when training our machine learning models. For example, when we are training a neural network, we want to update the model's weights based on how wrong its predictions were. And we can track this using the gradients. And PyTorch makes it super easy to calculate them for any tensor, basically. So we can also write it down as a code right here. So we need to enable the gradient tracking for a tensor. So let's say tensor c equals torch.tensor. First we make a random tensor. Then we put the requires gradient true in this tensor. So at the end here, we will put requires gradient true. And just for simplicity, we put decimals here. Make it a double. Okay. So now we can, for instance, perform an operation on this tensor. Because when we set the requires gradient equals true, PyTorch will start tracking everything that happens to this specific tensor. And later, when we call the backward function, using this tensor, PyTorch will be able to calculate the gradients automatically. So let's do, for instance, just a random operation. Result equals tensor c times 2, for instance. Okay, then we can find the gradients now using result.sum.backward. And finally, we just print this to see the gradients. Print f, let's say, gradients. And we can just print out tensor c dot gradient. So now let's run this. As you guys can see, it shows that we have created a tensor, and after multiplying it by 2, we calculate the sum and get back the gradients. And here you'll see the gradients over here that's printed. And this is the first step in training the models, actually, because calculating how much each parameter needs to be updated based on the error it produces is very important. So now that we have seen the basics, I want to take a quick look at how we can set up a just simple training loop. And this loop will give us a rather introductory taste of how a neural network or a model actually gets trained in PyTorch. So we just open the VS Code again, or your coding terminal, and we write the following codes. So first we make some tensors, x equals torch.tensor. Then we can make one point zero to 3.0 and 4. Okay, so after making this, we also set the required gradient to true. So let's make this in a list. So requires gradient equals true. Then next we can make a y tensor. Y equals torch dot tensor 2.0, for instance, let's say 4.0, 6.0, and 8. Okay, so, and we can now write a line of code that will create a very simple model. It will, let's first write it. So it's actually very simple here. Model equals torch.nn.linear 1 1. So this is just the simplest possible model that can be generated. It takes one input number and outputs one number. And it's inside this model that PyTorch will automatically be able to create the weights that will and assign them randomly. So now for this model, we need to add a loss function that will show how wrong the prediction is. So to make this, simply we just add a line criterion equals torch.nn.mse loss. And we can just leave the parameters empty for now. So basically this will, in this criterion, show how wrong the prediction is. And based on this, we now make the optimizer, which will now update the weights based on the loss function. So these two are quite essential for each other. So we write optimizer equals torch.optimizer.sgd. Then we set the parameters empty again, and we will also need to set a learning rate. Model.parameters and learning rate, let's just set something small, 0.01. So 1%. And now we come to the main part of this code, is the training loop for the model. So we can see how a model actually trains. So let's say for epoch in range 100. So we'll run this 100 times. We make model.train, basically optimizer dot zero gradient. So this will reset the gradients each time we run the loop. So to make it more accurate, because we have to reset the gradients each time, otherwise we will be using the previous gradients of the previous loop. So each time there's a new loop, we need a new set of gradients. Then we make the forward pass, which will help the model, or in other words, show that the model makes a prediction. So basically we write predictions equal model X. And using this, we compute the loss. So loss equals criterion predictions Y. And now the backward pass, as we did earlier, again to compute the gradients. And this time it will be for the loss backward pass. And remember this, in order to use the backward function, you must have, from the previous one, requires gradient set equals to true. Otherwise, it's not really possible to track them. So we just said loss.backward. And now optimizer.step optimizer dot step. This is to update the parameters now. And if epoch, we need to do a sanity check. So if it's divisible by 10, print f epoch and we can actually add more to this. We can just say epoch plus 1 divided by 100 to make it more accurate. Divide by 100, and now we set the loss. So loss will be equal to loss.item, and you can also control to how many decimals. So here we can just put to the 4th decimal. So here we have the simple just training loop. So we're training the model on a small set of inputs, like the tensor that we added here, the X tensor. And after giving this their inputs and their labels, so X and Y, the key parts of the model will be able to use the forward pass to calculate predictions and the backward pass to calculate the gradients. And after the gradients are computed, we will use the optimizer to adjust the model's weights based on the loss. And this loss, as I said, is just calculated using the loss.backwards function and getting their gradients. And here you see 1 out of 100, loss is 66. And as you guys can see, once we start training each time, the loss starts decreasing. And this is totally expected because the model will keep on training and training until it gets better on the data and being adjusted. So by the end, as you can see, our loss will be really minimal compared to its initial loss. So this model and this loop alone should give us a pretty clear view of the basics of how the models actually train and work. So yeah, we have covered a lot today. So in this video, we learned how to create and manipulate tensors, understand the algorithm behind autograd for gradient calculations, and we even made the simple training loop that shows us how the models basically work. And PyTorch really makes it easy to get started with deep learning, with machine learning, and these are the essential building blocks for more complex models. And this is why in this video I wanted to cover PyTorch more specifically. And in the next video, we can dive deeper into neural networks and how to train even more advanced models. So if you found this tutorial helpful, make sure to like, share, and subscribe for more content. Thank you for watching, and I'll see you guys in the next video.